Hi everyone, welcome back to High School Science 101. Today we are going into physics and we're looking at forces. And I'm going to explain and demonstrate a few different types of forces for you. Let's get started. A force is basically an interaction that causes an object to start moving or speed up, stop moving or slow down, change direction, or change shape. This interaction can be in the form of a push, a pull, or a twist. We can classify forces into two main groups, contact or non-contact forces. As the name implies, contact forces require physical contact between two surfaces. For example, I'm applying physical force to this putty so I can change it into different shapes. There is physical contact between the source of the force, my hand, and the putty, so therefore this is a contact force because there is physical contact between the two surfaces. Another great example of a contact force, or a byproduct of contact forces, is friction. And I would recommend watching my video on that because it covers it in a lot more detail and also gives you some examples on how to increase and decrease friction. Earlier, I said that there were two main groups of forces, contact forces, which I've just shown you, and non-contact forces. So let's take a look at a couple of those. The first one I'm going to talk about is magnetism. Magnets don't have to physically touch each other for them to affect each other, so therefore magnetism is a non-contact force. In this example, and in fact any example of non-contact forces, there's an invisible field around the object, and the non-contact force will act on any other object that enters that force field. So you can think of this force field as the range of the non-contact force. If something is outside of that field, outside of that range, then the non-contact force won't be able to act on it. A question that I get asked a lot is why are some things magnetic and some things not magnetic? And I can give a very simplified answer to this. Everything around us is made up of these tiny building blocks called atoms. And inside an atom, you have a positively charged particle called a proton, a neutral one called a neutron, and they are stuck together in the middle of an atom in the nucleus. And flying around the nucleus, you have these negative particles called electrons. In the atoms of most things around us, these electrons are flying around the nuclei fairly randomly, and overall the object doesn't have a charge. However, in some things, specifically things made of iron, nickel, or cobalt, all these electrons fly around the nuclei in the same direction, and this creates an invisible magnetic force field and makes the object magnetic. Additionally, every magnet has two different ends, a north pole and a south pole. If you try and put two poles of the same type together, like two north poles or two south poles, they will not attract each other. In fact, they'll try and push each other away and repel each other. On the other hand, if you put two different poles near each other, a north pole and a south pole, they will attract each other. Another example of a non-contact force is static electricity, and you might have noticed this when you've touched something metal and you feel a bit of a shock from it. To explain how this one works, we need to talk about electrons again, and just a reminder that electrons are the negatively charged particles within atoms. When we rub two objects together, sometimes the electrons from one object jump across to the other one, and so the object losing electrons, losing negativity, becomes positive, and the one gaining electrons becomes negatively charged. And so these two objects then are attracted to each other because one's positive and one's negative. Sometimes other objects will become attracted to these things that have charges. For example, if I rub a cloth against a balloon, the electrons will transfer from the cloth to the balloon, so the cloth becomes positively charged because it's lost these negative electrons, and the balloon becomes negatively charged. And now if we hold the balloon up to some things, they'll be attracted to it because it has this negative charge. The last non-contact force that I'm going to talk about is the one that affects you every single day without you even realizing it, and that's gravity. When you think of gravity, you probably think of space and planets and moons and stars, but according to Isaac Newton's universal law of gravitation, anything that has a mass has a gravitational field. So for example, there's a gravitational pull between yourself and the computer in front of you, but you don't notice it because it's so small that it's barely measurable. We do notice it when we look at bigger masses, because the bigger the mass, the more gravitational pull it has. And so that's why we tend to really associate it with planets and moons and stars, because those masses are much, much bigger. It's not only the masses of two objects that affects how much they'll be gravitationally attracted to each other, but also the distance between them. And in fact, the distance between two objects has a stronger impact on whether they'll be attracted to each other than their masses. The bigger the distance between them, the weaker the gravitational field. That's it for today. I've covered briefly what a force is and also some different types of forces. When we cover this topic, I also talk about balanced and unbalanced forces, but I might leave that for a video later on. Thanks for watching, and I'll see you next time.